we're going to go ahead and work a problem that involves friction and centripetal acceleration. So this says the coefficient of static friction between tires in a dry road is 0.65. On an icy road, it's only 0.25. If a flat turn has a radius of 60 meters, what is the maximum speed you can navigate the corner in clear conditions and in icy conditions? Right? Well, why does friction matter? Well, as I mentioned earlier, there is only one thing that can provide centripetal acceleration. So I'm going to draw you a top-down view first, and then we'll look at a view from behind the car. Okay? When something's turning a corner, let's actually look at it in two places. The straight part of this road, the forces on this car are all balanced because the engine's providing a force forward, there's air resistance and friction backwards, and gravity's coming straight down, and the normal force is straight up at us. But all those forces are balanced because as long as this thing is moving with a constant speed, the acceleration is zero. However, once we actually enter the corner and the car is now going this way, it's changed direction a little bit. Well, the front and back accelerations are still the same. They're zero. It's not speeding up or slowing down that way. The normal force and gravity haven't changed at all because this is a flat turn, so that hasn't changed. But now it's turning in this corner, which means we have some centripetal force this way. The only thing that can provide that force is friction. Now remember, inertia wants to keep the car going straight. It wants to go this way. The force that opposes motion is friction, so friction opposes that, and it actually turns it into the corner. Okay? So if there's no friction, we can't turn this corner. And depending on how big the friction is, we're going to have different speeds at which we can navigate this corner. So I said I would also look at this from the rear view. So if you have your car, right, I'm looking at this from the back. So I have my two tires, and then, right, here's the bumper, and then here's my car, and my driver's over here driving. Cool. All right, so like I said, there's gravity pulling down, and there's the normal force pushing up, and those two things are balanced. And as long as we're not turning, those are the only two forces I care about. But when we are turning, then we have the centripetal force towards the center, Fc, and that is given to us by friction. Okay, so the friction is got a maximum value. It's given by its coefficient, and Fc is always going to be less than or equal to the static frictional force. It can't be greater than that because there's nothing else that can provide that force. And we know the static frictional force is equal to the normal force times the coefficient of static friction. And since these two forces are balanced, what we really know is the normal force is equal to mg. So let's go ahead and start doing this. It says, what is the maximum speed you can navigate the corner in clear conditions? So we're going to start with that. And so with clear conditions, my coefficient of static friction is 0.65. I know the radius is 60 meters. How can I get a speed from this? Well, I know that means let's see, if I know the static frictional coefficient, my maximum static frictional force is equal to Fs equals mg times 0.65, which I can get almost a number for. I don't know m, so I'm just going to leave it m, but I know g is 9.8. So 9.8 times 0.65 gets me 6.37. So the static frictional force is m times 6.37. Well, since the static frictional force is Fc, or less than or equal to Fc, what I'm going to do is I'm going to say, well, centripetal force, the force around that corner, is less than or equal to my static friction, which is the mass times 6.37. But we also know that centripetal force is equal to mass times centripetal acceleration. So I'm going to go ahead and I'm going to put that in for Fc right here. So now I have mass times centripetal acceleration is equal to mass times 6.37. And I can see, oh, mass is here and here, so it divides out. So I'm going to get the relationship that centripetal acceleration is 6.37 meters per second per second. But I wanted to know a speed. Well, I know one more equation. I know that centripetal acceleration, AC, is equal to velocity squared divided by the radius. So I'm going to go ahead and I'm going to find the radius. It was given. It was 60 meters. And so I can say 6.37 is equal to v squared over 60. Multiply both sides of this equation by 60, and I get v squared equals 60 times 6.37, which is 382.2. And if I square root both sides of that, then I can tell you that the maximum speed this thing can navigate is, so v is 19.55 meters per second. If it goes faster than that, then the static friction force is not big enough to create a big enough centripetal force to keep it moving in a circle. So velocity is 19.55 meters per second. That's on nice dry conditions. What happens if we hit icy conditions? Well, the only thing I have to do is I have to go back in and I have to change this right here. Instead of this being 0.65, it's 0.25, which changes this number from 6.37 to 9.8 times 0.25, which is 2.45. Okay, and then that means down here, when I have centripetal acceleration equals v squared over r, I'm going to use 2.45 times 60 and square root that. And that gets me 12.12 meters per second. So considerably slower because it's icy out, and that's why when it's bad conditions, when the road is wet, when the road is icy, everybody encourages you to slow down and take your time, because not only is it harder to stop, it's harder to make turns, and it's easier to lose control, and it changes the driving conditions. Okay? So not too bad, but we did have to use a lot of relationships in order to get this. We used what we know about the normal force and gravity. We used what we know about coefficient of friction and the normal force. We used centripetal force, we used Newton's second law, and we used centripetal acceleration equals v squared over r. So there are a lot of equations coming at you, but not very many of them are new. You just have to remember how to use them.